The Great Morning Planet Show of May 2011, presented by Science at NASA. Waking up before dawn can be a drag, but for the next few weeks, there's a good reason to wake up early, and something to open your eyes even better than coffee. 4 planets are aligning in the morning sky. Look out any east-facing window before sunrise. If you have a clear view of the horizon, you'll see Mercury, Venus, Mars, and Jupiter clustered together in a patch of sky less than 10 degrees wide. If you wanted to, you could hide them all behind your outstretched hand. But don't do that. The view is too good to hide. The best mornings are the ones around May 11th, when Venus and Jupiter converge to form a tight pair side by side. They are so bright, they might fool you into thinking you've witnessed a double supernova beaming through the morning twilight. But no, it's just 2 of the brightest planets in our own solar system. The quartet of worlds will rearrange themselves on a daily basis, forming different shapes in the pre-dawn sky. On May 8th, for instance, Venus, Jupiter, and Mars will form a diagonal line. Trace your finger from Venus through Jupiter, and it will lead you straight down to the red planet. On May 13th, Mercury, Venus, and Jupiter will rearrange themselves as vertices on a bright celestial triangle, almost equilateral, a geometry lesson before breakfast. On May 20th, a new triangle will appear. This time, the vertices are Mars, Venus, and Mercury. The show comes to an end on May 30th, when an exquisite crescent moon joins the 4 planets for a grand finale. 5 heavenly lights dotting the eastern sky all at once. What a way to begin the day. For more information about the Great Morning Planet Show of May 2011, please visit science.nasa.gov. A space-time vortex around Earth, presented by Science at NASA. Would you believe Earth sits in the middle of a space-time vortex? Einstein predicted this almost 100 years ago, and it turns out to be true. On May 4th, 2011, researchers announced that NASA's Gravity Probe B spacecraft has detected the vortex, and its shape precisely matches the predictions of Einstein's theory of gravity. The space-time around Earth appears to be distorted, just as General Relativity predicts, says Stanford University physicist Francis Everett, principal investigator of the Gravity Probe B mission. Time and space, according to Einstein's theories of relativity, are woven together, forming a 4-dimensional fabric called space-time. The mass of Earth dimples this fabric, much like a person sitting in the middle of a trampoline. If Earth were stationary, that would be the end of the story. But our planet spins, and the spin should pull the dimple around in a 4-dimensional swirl. This is what Gravity Probe B went into space in 2004 to check. The idea behind the experiment is simple. Imagine trying to spin a toy top on the dimpled surface of that trampoline. It's going to wobble, right? Something similar happens when you try to spin a gyroscope in curved space-time. Its spin axis will drift or precess. Gravity Probe B carried some super-spherical gyros into Earth's orbit to see what they would do. In practice, this simple idea is extremely difficult. According to calculations, the twisted space-time around Earth should cause the axis of the gyros to drift by a tiny amount. Really tiny. It's like measuring the thickness of a sheet of paper held edge-on 100 miles away. Even the slightest disturbance could ruin the experiment. We had to invent whole new technologies to make this possible, says Everett. The Gravity Probe B team developed a drag-free satellite that could brush against Earth's atmosphere without disturbing the gyros. They figured out how to keep Earth's magnetic field from penetrating the spacecraft. And they created a device to measure the spin of a gyro without touching the gyro. Pulling off the experiment was a big challenge. But after a year of data taking and nearly 5 years of analysis, the Gravity Probe B scientists appear to have done it. The gyros precessed, the vortex is real, and we are in it. Einstein was right again. For more information about the space-time vortex and what it means to us on Earth, please visit science.nasa.gov.
Super flares from the Crab Nebula, presented by Science at NASA. In 1054, nearly 1,000 years ago, a star in the constellation Taurus exploded. The supernova was so bright, Chinese and Arab astronomers saw it in broad daylight. And, according to their ancient records, it remained visible in the night sky for 2 years. The dead gaseous remnant of the star has been expanding quietly ever since. We call it the Crab Nebula. New observations show the Crab Nebula might not be so dead after all. On April 12, 2011, NASA's Fermi Gamma Ray Space Telescope and the Italian Space Agency's Agile satellite detected an enormous outburst of gamma rays, more than 30 times more powerful than the nebula's normal gamma ray output. On April 16th, it happened again. These super flares are the most intense outbursts we've seen in the Crab Nebula, and they are extremely puzzling, says Alice Harding at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Harding and others think the flares are somehow connected to the Crab Nebula pulsar. At the heart of the nebula lies what is left of the original star's core, a superdense neutron star that spins 30 times a second. Each time it goes around, the neutron star sweeps a beam of radiation past Earth. It literally pulses us with electromagnetic waves, hence the name. For many years, these pulses were the only significant changes in the nebula's output of high-energy radiation. That's why the current outbreak of superflares is so surprising. The Crab Nebula exhibits high-energy variability that we're only now beginning to fully appreciate, says Rolf Buehler, a member of the Fermi Large Area Telescope team at the Kavli Institute for Particle Astrophysics and Cosmology. Scientists think the flares occur when the pulsar's intense magnetic field undergoes a sudden restructuring, a sort of starquake. Such changes can accelerate particles like electrons to velocities near the speed of light. The electrons, in turn, radiate gamma rays. To account for the recent flares, scientists say the electrons must have energies 100 times greater than can be achieved in any particle accelerator on Earth. This would make them the highest energy electrons coming from any known source in the whole galaxy. Dead star? Quiet nebula? Think again. For more superflares and other surprises around the Milky Way, please visit science.nasa.gov. A salute to Spirit, presented by Science at NASA. At NASA, missions are expected to go the extra mile. The best-known example, perhaps, is the Voyagers. Launched in the 1970s to explore the outer planets, the iconic spacecraft have zoomed far beyond their original targets to the edge of interstellar space itself, 9 billion miles from Earth, and still making discoveries. Pioneer 10 and 11, Ulysses, Stardust Next, Deep Impact, and others have similar track records. It's almost routine now for superbly engineered probes to wrap up their prime mission, then travel a few million or billion bonus miles for extra science. Against this backdrop of sweeping overachievement, we pause to salute a robot that might never move another inch. Well done, Spirit. For the past 7 years, Spirit has been on a journey as extraordinary as any mission in NASA history, says Mars Exploration Rover Project Manager John Callis of JPL. But now, it may be time to say thanks and farewell. NASA hasn't heard from Spirit in more than a year. The trouble began back in 2009 when the rover trundled into a sand trap, breaking through an apparently safe crust into soft sand below. Stuck in place, Spirit couldn't turn its solar panels squarely toward the sun. This curtailed power just when Spirit needed power most, during the deep freeze of an approaching Martian winter. Where Spirit is, winter temperatures drop as low as -130 C, far colder than any place on Earth, says Callis. Without sufficient electricity to power internal heaters, Spirit went into hibernation. NASA has used Deep Space Network antennas and 2 Mars orbiters to try to re-establish contact, but no luck. Whether the rover is damaged or merely sleeping, no one can say. But most engineers believe the possibility of contact is now remote. On May 25, 2011, NASA concluded the final transmission in its series of attempts to regain contact with Spirit. Spirit landed on Mars on January 4, 2004, for a mission designed to last merely 3 months. After quickly accomplishing its primary science goals, the rover went on to work for almost 6 more years. In all, Spirit has traveled almost 8 kilometers, explored several large craters, studied thousands of rocks, photographed Martian dust devils and sunsets, observed the moons of Mars, and taken the first picture of Earth in the night sky of another planet. Spirit also found evidence of ancient hot springs, steam vents, a thick atmosphere, and surface water in Mars' distant past. Alone, any one of these discoveries would have been considered a resounding success. Together, they place Spirit squarely atop the pantheon of NASA's great overachievers. This is a bittersweet moment, says Callis. Thanks again, Spirit, for all the great discoveries, and oh so many extra miles. For more information about Mars exploration, including Spirit's twin rover on Mars, Opportunity, please visit science.nasa.gov.